Okay, this is Andrew. I know some of you may probably already be done and some of you may be confused. So as promised, I'm going to do a little video to help out some with this problem. Okay, so basically here's our code from, just our sheet code from project 1, and then the PHP goes in here. So let's just zoom into that PHP area, and then this is generally an image of what your web page should look like, something like this. Not exactly, but so basically you have these four functions: add round key, subbytes, shift rows, and mix columns. So a good thing about this problem is, just like in real world, like they may run computers for months to sequence a genome, and when they get to an answer, nobody really knows if it's a right answer. Well, that's the same thing here, because we're not doing decryption, so we're not going backwards, and we're not doing the key expansion, so we can't just look and see if we're getting the same AES result if we went through an AES program. So we're getting a different result because we're not using the key expansion, so we need to know if our answers are right. And the way people do that is by looking at the input and the output of your functions and verifying that your functions are working correctly. If your function's working correctly, then you assume that your answer is possibly correct. So that's the idea. That's why I want you to put a table like this, which is the state, between each function here, because that's the input to the function and the output of the function, and then the output of this one is the input to the next one. So let's say you do shift rows. We'll take the output of subbytes and display it in the state table, and then take the output of shift rows and display it in another state table. And then I can just quickly look, right? I can say, okay, well, the first row wasn't shifted right. Okay, the second row was shifted by 1. That's correct. The third row was shifted by 2, and the fourth row was shifted by 3. Correct. So we know that the output, just like that, of shift rows is correct. Okay. So what you want to understand is this is done generally in a string. So you have two things going on. It's the same data, but some is in a string and some is in an array. Now when you look at add round key, this is going to be, let's make it a little smaller, but like an input box on your web page, right? And this is going to be an input box on your web page. And you're going to put 16 characters in, 16 for your password, 16 for your data. You can put less, and then it does need to have the pad key. We'll talk about that later. Right now we're talking about this. So let's just say you put 16 in. Alright, so you put 16 in here and you're 16 in here. So that's 1, 2, 3, 4, 5, up to 16 characters, okay? And that's going to represent 1, 2, 3, 4, 5, 6, 7, 8. Be aware these arrays actually start at 0, but I'm wanting you to get the idea that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 goes 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So then actually you have these two strings going into add round key. Okay, so let's say here's add round key, and then this string goes into add round key, this string goes into add round key. Now what's coming out? What's coming out is this string is the XOR of the two inputs, and it's got 1, 2, 3, 4, 5, 6, 16, and it's being rearranged through that code I wrote to display a table out here. So that's the output of your add round key, right? And then it's also generating at the same time an array. Let's just give that a different color. Alright, so an array. Alright, so it's generating this array. And this array coming out of add round key is going into subbytes. Going right into subbytes here. See that? So this is going to the web page, displaying a state table that's the output of add round key. And then this is going to subbytes. Okay, this is an array. Then out of array is going to come substitution, and it's going to go into shift row. So this is just where you're doing the S matrix lookup, right? So out of that S matrix lookup, then you just do like that, right? All right, so let's what's called pseudocode. Let's take a little look at some pseudocode. Let's put these back here for now. Get rid of that guy. Okay, so let's say you have your functions. Pretty much all of you did the functions in the discussion, so you know kind of how to define functions here. These could be separate pages or on this page, however you want to do it. Now, you're going to want to start writing the code now, right? Okay. So, the first thing I want to do is, this is pseudocode. This is not PHP code. So generally what you do is you're given a problem, you try to get an algorithm or a flow chart, and then you go into pseudocode, which is kind of code. It's not real code, but you're starting to turn the problem into code. And this is often another step. It's called pseudocode. So it doesn't really have to have any real perfect syntax. A lot of it is just what makes sense to you. So let's say x equals call add round key. Okay. Now add round key, you could pass these two strings to add round key, which might be the better idea. Or you could just have this read string 1 and string 2 off the off the web page. So add round key could just read them, or you get the idea. Alright, so now when we come out of add round key, we see that we have to have a for loop going 9 times. So let's just do that. For loop 9 times. Okay, so now in this for loop, the first thing we're going to do is call subbytes, right? But we want a return variable. So let's say x1 equals call subbytes, and you want to pass the array x. Now remember, this was the array, right? This x was an array, not a string. The string was printed up here on the screen on your web page. The array is being passed to subbytes. The string is going to be a table. It's basically going to be, you know, the 16 element table. And you want to have it right here so you can compare the input to the output. So when I go to this, when I come out of the subbytes, I want to see another one, such that I can compare the input of subbytes with the input of outbytes. And all I have to do is get a copy of the S table right here and look at it and say, okay, this one was H3, that's H123, that's this one right here, and yes, he has the right value in there. So these are going to be the strings, but what you're going to pass is the array. The array is what you're actually operating on. Okay, so after subbytes, we want to return a variable, and we want to call shift rows, and we want to do that with the array x1. So remember, okay, that's clear enough. So after that, x3, sorry, I still have a cold. You want to call mixed columns, right? you want to call mixed columns using x2. And then you want to call return variable, and you want to call add round key again. But this time, you might have to look it up, but I think it's implode. Implode turns a string, an array to a string is what you want to do. Because if you remember, this add key takes a string in off of the web page. This add key is the only one that takes a string as an input. So you want, this is an array, this x3. So you want to convert, if that's not the correct command, then just look up the correct command. Okay, so you want to upload x3, that converts it to a string. Okay, so now x4 is the end of this loop, so that's the end of the loop. So it's going to do that 9 times, but I think you just want to print out the first time. You might want to be able to put some way that you can step through here so it breaks the program, and then you have a button where you step here. That's up to you. Okay, and then next after this you do sub bytes. So let's say y1 equals call sub bytes. We've been down this road before, and we're gonna use x4, right? And x4 should be an array, so y1 should be an array. That should work well. Okay, so next we want to call shift rows, and that's going to be with y1. Now remember, again, for all of these, this is this is the array, and that's, but you're also going to have a string, and the string is going to be put up here. The string is going to be taken 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but really starting at 0, so you get the idea. So call y2, so y3 equals, you skip mixed columns here. That has to do with the decryption. Okay, so you want to call add key, and again, what's the problem here? You're passing it a array, and it needs a string. So again, you want to do the command. I think it's implode, whatever the actual command is. Be sure you use the right one. y2. Okay, so, and that should be it, right? So that's it. About once you get these 4, you're gonna have to do pretty much just one more thing. Is you're gonna have to do the pad key, the pad function. If they put in 8 here, you got to be able to pad it with something. So you might want to do maybe another input box here is pad, call it pad value, and then if they enter a 4, just one character, then the first 8 or whatever they enter, and then the next 8 is padded with a 4. Okay, so because they have to be in blocks of 128 bits or 16 bytes, there's no option. So if you're short, then you have to pad this up to 16. Okay, so I think that's all for now. This shows you, I hope it helped you. If not, well, too bad, but I hope it helped. But basically this is showing you a general idea in some detail, a pseudocode of how to integrate these functions into your final program. So this is assuming that the functions are working, right? Then this is the pseudocode of how you'll actually integrate your entire program. So I hope it gives you an idea of what should be on the web page, how the web page should look, how the functions should be called, and So now we've done the add round key basically. You might have to clean it up a little. I'll go over that code a little bit. I'm going to do some live demonstration on that code next. And then you have to create this sub bytes, which is just a lookup table substitution. That should be pretty simple for you. And shift rows should be pretty simple. And mix columns should be pretty simple. I mean, basically, if you use that PDF document I gave you, it's showing you the equation for each cell. So you'll just have 16 equations and one in each cell, and you're done, right? All right. So keep your eyes out for the next video. Let me know if this one helped you or not. If it did, I'm glad. If not, well, sorry.